Okay, so this is going to be a tutorial aimed at people following or have finishing the Isometric Tactics tutorial series that I made a while ago, and it's going to show you how to avoid making all of these different sprite resources and having to organize them and to still get the same effect. So just to kind of refresh people's memories, at the moment for you, we have a list of grids. That stuff is going to stay the same. It's only how we create the sprites that's going to be different. We used to do the creation in the create event, like, where is it? This bit here, this for loop took care of it. And I thought it was a good way to do it because as long as you organize the sprites in the correct order, then you can just add them one by one. And you know they'll be in the correct order for the game, but it's actually pretty laborious, and there's a better way to do it that I've found. I wish I'd done it this way before. It would have saved me and you a lot of time. So the way that I had to do it before was we have an enumerator. Zoom in on it. So we have this enumerator which has all the characters and all the classes and the 4 characters, and we had to and we have these different states as well, like these 5 states. So for each class or character we have 5 different states, and we had to create a sprite resource. So right click, create sprite. Although, and I think now you can create more than one, but it's still pretty laborious. You have to create the sprite, name it, add the correct sprites to it, the correct image indexes, and also we had to organize it so that we always had west, north, east, south for every state. And it's just a really laborious process. For example, you can see in each of these folders there's 4 different sprites. Here's like one animation like this. So it's easier for me just to use a bar than to have someone make a proper animation, because the proper animations take a lot of work. So each state has 4 sprites. The sprites can have plenty of different images, for the animation. And then if you multiply that together, that's 5 times 4 is 20 different sprite resources per character or class. And we have 20 characters and classes, so 20 times 20 is 400 sprite resources we have to create, name, add sprites to, all that kind of stuff, and maybe even organize into the correct order before we can even use them in the game. And it's just like a really laborious way to do it. So what is the alternative? Well, let me open the final version. So if I go into the sprites here, isometric units, so all we have in this one now is the actor, the default one, the one that the player shouldn't see. And I only kept it in because I used some of it. I referenced this sprite sometimes during the game just to get the dimensions of the sprite. That's the only reason I've kept it in. And here we have 2 sprite sheets. One for the player units, one for the enemy. You can use as many sprite sheets or as few as you want. The process is exactly the same. It's just we're going to have one list of grids for each sprite sheet, and here is every sprite for one single character or class. This would be a single grid, this stuff here, and I've actually created a little paint thing just to kind of explain that in more detail. So for every sprite sheet we'd have a global list. So you guys just have one global list because we didn't have separate sprites for the enemies. So we have one global list. Each character is going to have its own grid, and each cell in that grid is going to have a different sprite. So in cell 1-1, we have a character facing north with an animation, and if we go to our states in the main object. So the first state is idle. So that would be the idle animation. This paint isn't reflective of what the actual grid would look like, because as you can see, our first entry is empty, it's not used. So in every grid we have for the characters, this column wouldn't have any sprites in them because we don't use it in the game. So this column here would be idle, and then the second column here would be attack, because attacks second 1, 0, 1, 2, etc, etc. And we're just storing this. We're just creating a sprite resource and storing it in the grid via code. We don't have to manually do anything ourselves. So it's a lot faster to do it. You know, it's a big time saver. One person has asked me if we look at the sprite sheet, so you can see that all of the sprites have the same number of images, and they are the same width and height for every character, and that's not always going to be the case that you want. This code is just going to be for this, but I'm also going to give you hints on how to change the code to allow you to have different sized, different widths and heights, or animations of different sizes within the same sprite sheet. And for it to still work, it just requires extra setup. I'll explain that as we code it. So hopefully that explains the changes and what we're going to do. In terms of making changes to the code yourself, all you need to do is get rid of the for loop. Let me go to the other one. So in the project, in OBJ main, this is where, in the create event, so we have a region. We have an area where we create the global character sprite grid, which is a list, and then we just add all of our sprite resources to different grids for each character. So what one character has a grid, and then we add the grid to the list. We're going to be doing the same thing, but without having to make 400 sprite resources. But you can just delete this, because we're going to do it in a different place now. I'd make a backup your project before you do it, just in case you make a mistake as well. So what we're going to do is, in our main object, we have a draw event. It's a new event. Okay, so let's get on with the code now. We start with if sprites created equals false. Obviously, we have to initialize this somewhere. So we're going to do it in the create event of obj main. Is it the right place? Yeah, there we go. So sprites created equals false. After we've created all our sprites, we're going to set it to true. So that this only ever runs one time, because what happens is the game's going to start. OBJ main's our first object. It runs the create and the step event, and then it runs the draw event. And this is the perfect time to create our sprites. So after we have created our sprites, we just set it back to true. I'm only going to be showing you this region because this one is exactly the same code as this, just a different sprite sheet name and different global character grid list name. So and if you're just using the same characters and sprites for both the player and the enemy, you only need this one anyway. So let's open the region. If you just copy this stuff for now, so you have the basic outline. So I'm just going to explain to you what's going to happen here. So the first region is going to create a surface. So we can't just draw the sprite sheet and copy from that. We have to actually make a surface, and the sprite sheet's basically going to become the background for that surface, and we can make sprites based on that. Then we're going to make our list of character sprite grids. each entry is going to be a different character grid. Each grid is going to have a sprite in each cell for that character. We're going to set up our variables, and then we're going to go through our sprite sheet, left to right, top to bottom, creating sprites, adding them to a character grid, saving that grid to our list. And then you always want to reset the target for a surface and then free the surface. So that's the overview. I'm going to go into this in more detail. So like I said, the first thing we want to do is create a surface. You always want to check to see if a surface exists before creating it, and just to make sure that it's still in existence. The width and height of our surface is going to be the width and height of our sprite sheet, and then we just create the surface based on that width and height. You have to set the target for the surface as well, and then we're going to draw our sprite sheet to it. So that's that region, and then we're going to create our list of character grids like that. So setting up variables, the first one we have is 4 images per animation. Basically every character in our sprite sheet for every animation just has 4 frames to make it simple. You might want to have a different number of animations per state for different characters, so this number might want to change. How would you do that? Well, if it was me, I would just create a grid, and for each character, for every state, I would tell that grid, okay, well, for this character, for this state, there should be 5 frames. For the next state, there should be 4. For the next state, there should be 6. And then images per animation will just change based on that grid. And then actions start to actions end. If we look at the sprite sheet, we don't want to start here because it's empty, but we want to start here where it's idle. And actually, the way the code is, it kind of treats this whole sprite sheet as a grid. And this cell here is 0, 0, and this one here is 0, 1. We want to start from here, which is 1, 1. Facing and total facings, that's just going to deal with north, south, east, and west. An image width and image height is the width and height of each image. Again, you might want to have characters of different widths and heights, and you can do that and use the same code. Again, you just need to do some extra setting up, whereby you you store data to say, okay, for this character, for this state, it's got a width and a height of X and Y, and then you just need to update image width and image height per character per state in this for loop here, and it'll work. Again, if there's enough interest, I'll just I'll update the code and show you how to do it. So before I go into the meat of the code, which is here, this for loop, I'm just going to show you the sprite sheet again and explain what's going to happen, and then just show you the code. So what's going to happen is we're going to start here. We're going to determine the X and Y coordinates for this spot here. Then we're going to create a sprite sheet. So we're going to create a sprite based on this image. Then we're going to add the next 3 images to it, and we're going to save that whole sprite to the character grid. Then we're going to create a new sprite based on this image, add the next 3 images to it, and then save this whole sprite to the next cell in the character grid. And it's going to do this for all of these sprites, and then all of these sprites will be saved into the character grid. So hopefully that kind of explains what it's trying to do, or what it's doing. And here's the actual code. So for every character we have, we want to create a character grid. We want to make sure we create sprites for every one of our 4 facings. And again, we're doing it left to right, top to bottom. So for the first facing, we're going to create all of our sprites and add them to the grid. Actions start and actions end is the idle. to the dead state, remember. X point and Y point is this. Sorry, so if I zoom in and I mark it, so this is the X point and Y point for the first sprite. This is the X point and Y point for the second image. This is the X point and Y point for the third image. This is the X point and Y point for the fourth image. So it's just going to update X point and Y point, and then copy this image, and then add it to the existing sprite, which we haven't got to yet. I'll show you that next. So X point, Y point. This one here, this line, which I've spread onto 2 to make it easy to see, so I can increase the size of the font. This one here, character grid x y y equals sprite create from surface. So give it our surface. Where do we want to copy? At what point in the sprite sheet do we want to copy the image from? How wide do we want to copy it? How high do we want to copy it? Do we need to remove the back? No, because it's transparent. Do we need to smooth it? No. This stuff here, the X origin and Y origin is the same as if you went into a sprite like this guy here, and then if we change these numbers here, that's exactly what that code does. So it's just to make sure that everything's being drawn in the correct place when we draw it in the game. That's what X origin and Y origin is for. So we've got a character grid. We've created a sprite with 1 frame, 1 image. And then for the next 3 images, we can now add from surface. We're going to add to this sprite stored in character grid X, Y, Y, which we created here. We're going to add it from the surface. We're going to update X point and Y point. And again, we're going to give it the width and height. And then that gives us the next 3 images for the sprite. And then after all this is run, then we have filled a character grid with all of the sprites for that character. So we can just save that character grid to our list like that. So if I minimize this now. So once we've done our for loop, because this will happen for every character because of this for loop, we've got a global list with a grid for every character. Each cell in that grid is a different sprite with 4 images. We can just reset the target and free our surface, and that's it. I hope that wasn't too complicated to follow. I will catch you next time. Bye for now.